Hello eye-tracking community. My name is Michael, and in this video we will talk about dynamic areas of interest, gaze statistics, and the new release of Blickshift Analytics. So let's start with the demo. I will show you 4 use cases: an head-mounted eye-tracking experiment, an automotive setup with fixed cameras, an eye-tracking experiment with a website, and an experiment in virtual reality. On the screen you can see the head-mounted perspective of the participant. The task is to build paper planes. We have the instructions here, and they are covered by a dynamic moving area of interest. So when we go through the recording, we can see that the instructions are following the papers. And now I would like to add another area of interest covering the paper and the hands. So I create here an area of interest. I give it the name paper. And then I go a bit forward. And after a while, I readjust the area of interest. And by doing so, I go through the whole experiment, and I'm covering always the paper here step by step. So it's very simple to create areas of interest in Blickshift Analytics for a head-mounted experiment. In the second experiment, I will show you how we can annotate an automotive eye-tracking experiment. So here we can see a driver driving his car or her car along a road. We have different other cars on the other lane, and then this driver is approaching a traffic light. And now I want to annotate the traffic light, and since it's dynamically moving, I can use here the Dynamic AOI editor. So we can see here the traffic light. So I call it traffic light. And then I can use here the time axis with the higher resolution, and I can readjust the traffic light. And so by doing so, I go through the experiment, cover the traffic light. Now we have 2 traffic lights to be exact. So perhaps I decide to go with the upper traffic light. And then, yeah, of course, it's now here on the right side. When I go through the experiment, I can see we have now the areas of interest for the cars and now for the traffic light. The third use case is to create dynamic AOIs on a website. A very usual task in eye-tracking research is to analyze how people are reading visualizations or information from a website. And sometimes you have access to the object model of the browser, sometimes you only have a screen recording. And here, in case of a screen recording, you can easily select the areas or create the areas of interest, and they are then moving along with the visualizations on the website, as you can see here in this example. So I scroll here a bit forward, and then the screen recording will scroll down, and then after a while we have here the call to action button, so it appears here, and now we can analyze the eye movements with these areas of interest. The final use case which I want to show you for the Dynamic AOI editor is if you don't have access to the rendering model in a virtual reality scene and you only have a screen recording as well. So it's a bit similar to the case of the website. So here we have a 3D scene created in Unity. We have 3 visualizations, and here you can nicely see how this dynamic area of interest editor can be used to cover these visualizations hanging virtually somewhere in space. And now you can continue from there with a detailed pattern analysis or statistical analysis. Statistics is the right keyword for showing you the next feature of our new release. It's our gaze statistics node. On the screen you can see the scan paths of the user study I've shown you in a previous video, in the previous videos. We defined some areas of interest and we wanted to analyze how people are reading here information in this diagram. The gaze statistics node now computes many more metrics than the old one. So the old one computed total gaze duration, normalized gaze duration, average gaze duration, maximum, minimum gaze duration, gaze count, time to first fixation, and gazed at by. Not bad, but not enough. And you ask us if we could implement a node which computes many more of these metrics. And yes, we are doing that, or we did that. Now, this node also computes the AOI transition rate, the fixation count, saccade count, gaze point validity, average values, fixation rate values, ratios, and different metrics about the scan path lengths. And since reading tables is sometimes difficult, you can combine it with a diagram visualization. And here you can see the fixation count metric on the whole stimulus for the first 5 participants in the experiment. And now you don't have to use external scripts for computing these metrics. You can do everything right out of the box in Blickshift Analytics, and you can export everything here via the output context menu to CSV files, and from there you can further analyze them in other statistic software. Thank you very much for watching this video. If you liked the video, please press the like button, subscribe to our channel, share it with your colleagues, and I'm very looking forward to the next video.